All right, hello. This lecture will be on momentum and impulse, chapter 6. To start off with, momentum is a property of moving things. And in essence, it means inertia and motion. So something that has mass has inertia. And if that mass is moving, it has momentum. Only moving things have momentum because momentum is mass times velocity. So if something has zero velocity, then it has zero momentum just by nature of the equation. So if I plug any mass into the equation, momentum equals mass times velocity. If the velocity is zero, then the whole thing becomes zero. The way I would write the equation in variable form is lowercase p equals lowercase m times lowercase v for velocity. Momentum, the abbreviation for momentum is not m. There are a lot of m abbreviations in science, and there just aren't any left for momentum. So p is the symbol for momentum. Go ahead and fill in the answers here. The answers are coming straight from this discussion as well as from the slides. You're able to just simply translate that over into each question. When comparing the momentum of two objects, we have to look at the masses and the speeds. If they have the same speed, then the larger mass will have more momentum. If they have the same mass, then the faster will have the greater momentum, just mathematically. So remembering that equation was momentum equals mass times velocity. So in other words, a moving boulder has more momentum than a rolling stone, meaning like a smaller boulder, right? And then if we compared two boulders, the faster one would have more momentum, and a boulder not moving would have no momentum. So if velocity is zero, just by nature of multiplication, there will be zero momentum in an object that is not moving. So you should be able to answer questions 3 and 4 based on that. Next, we have a practice question. A moving object has momentum, energy, speed, or all of the above. Now, we define momentum as moving inertia. So it is definitely something that a moving object has. So A is definitely correct. Energy we haven't talked about, so maybe you're not sure about that one. Speed. So using the word velocity and speed interchangeably at this moment, for an object to have momentum, it must have a speed that is not zero. So any moving object definitely has speed and momentum. Since we don't have a choice to choose A and C, then that makes our answer D, all of the above, which means that any moving object must also have energy. We could determine that from this question. All right, next question. When the speed of an object is doubled, its momentum what? Our equation is momentum equals mass times velocity. If I plug in a mass of 1 and 1 for velocity and mass, I get a momentum of 1. If I leave mass the same, because it doesn't say anything about mass changing, but I double velocity, so instead of a 1, it becomes a 2, what does momentum become? And so we can just see mathematically here that it goes from being 1 to being 2, because 1 times 2 would be 2. So this answer would be 2. So it doubles. All right, the next concept we're looking at here is impulse. Impulse is very closely related to momentum because impulse is essentially a change in impulse. Impulse is a change in momentum. So when the momentum of an object changes, that would be what impulse is. Impulse can also be measured in force over time. So if I apply a force over a short period of time or a force over a long period of time, that changes the impulse. Imagine if you are like pushing someone on a swing. If you push them just like whoop, versus a longer push, you're applying the same amount of force, but over a different amount of time, the change in their velocity for their swing will be different. So if you just kind of go up to someone and go whoop like that, the swing isn't going to speed up very much. But if you push for a longer extended period of time, you get a bigger impulse, which is a greater change in the momentum of the object, which is visible as a change in velocity. Okay, so you're increasing the speed or changing the speed the most. with a longer application of force. All right, for question 7, we're looking at the impact equals force times time portion of the equation, and we are holding time constant. We're holding force constant. So if we have impulse, all right, so same as when we were predicting what happens to momentum when we change velocity, we're looking at what changes, how does impulse change when we change time? So we have a force that is constant. So I went ahead and plugged it in as a 1, time as 1 to give us an impulse of 1. Then if I were to double time, so spend twice as much time applying the force, then I will change my impulse. I will actually double it. So it'll go from 1 to 2 in this example. For the rest of this lesson, you'll be answering the questions here. Read carefully. So no, question number 8, it states the momentum of an object depends on the object's what? Pick 2 quantities. A, mass, how much stuff it has. B, so A is on the different line. That's the only part you have to be kind of careful with this problem set, is that some of the letters are not in the right place. So A is on the previous line, and so there's A, B, C, D, and E. This one, they're just kind of close together. For this question, the A is again way over here. So A is 2.0 kilograms per second. B is 7.2 kilograms per meters per second, right? C, 6.1, and so on. You can kind of go through them. The 2 quantities needed to calculate an object's momentum are, consider the mass and velocity values of objects A and B. Well, it says below, but they're over here on this side. They have the same velocity and they have different mass. Calculate the momentum of a 2 kilogram brick moving through air at 12 meters per second. For number 13, you would include, if we're including units here, we have a mass of 2 kilograms and a velocity of 12 meters per second, giving us a momentum of 24 kilogram meter per second. So those are the units for momentum. It's kilogram meters per second. So if you see something with a different unit, then that would not be momentum. Looking back up here to question number 10 here, the very first one is kilograms per second. So we know that's actually incorrect because the units for momentum should be kilograms meters per second. So you would have to look and see, you can immediately eliminate any of them that don't have those units, kilogram meter per second. All right, and that should do it.